Welcome everyone who is on this seminar presentation today. My name is Bradley Flam. I'm the Director of Westchester University's Office of Sustainability, and I am honored to welcome you and to give credit for this seminar series. It's a joint initiative of our office along with the Office for Research and Sponsored Programs, the Office for Digital Innovation, Digital Learning and Innovation. Did I get that right, Kristen? Yes. And the Sustainability Council's Scholarly and Creative Activities Committee. We're all proud to be able to bring this series of 12 presentations to the Westchester University community. We are on our fourth week of this semester. We have 8 fascinating presentations lined up for the rest of the semester. If you haven't yet seen our program, go to wcupa.edu/sustainability, and you can find at the bottom of the page the full program for this semester. So thank you for joining us today, and without further ado, I would like to pass the digital floor over to our speaker this week, Mr. John Lattanze.
Okay, thank you, Brad. I'm just going to share my screen here. Okay, can everybody see the screen? Okay, very good. As Brad said, my name is John Lattanze. I'm the Energy Project Manager here at Westchester University. And I was invited here today to speak to you about energy management and its effects on sustainability here at the university. I thought I'd start out just by giving you an overview of my role here at Westchester as the manager, as the energy manager. First of all, I'm responsible for recording and reporting all the usage and costs associated with the energy sources we use here at Westchester University, as well as the major utilities. We take this data, we evaluate it, and we hope to identify areas where we can reduce and where we could actually use it a little more efficiently. I'm also involved with energy-related projects, and by this I mean hard projects, which involve installations of new equipment, modifications of existing equipment, and also, as far as the geothermal system goes, I oversee the installation of well fields as well as the modification of our existing pipe work in the distribution system. So any projects related to that, I'm usually involved with. But I'm also involved with what I call soft projects too, which have to do with data analysis and actually evaluating the performance of a lot of our systems here, including geothermal and other systems in the building. And I'm also actually responsible for the operation of the geothermal system here at Westchester. We monitor this system daily. And in doing so, we actually make seasonal adjustments to this geothermal system too, to make sure we're operating as efficiently as we can. And we do our share of troubleshooting, but we actually hope that by this daily monitoring, we could actually identify potential problem areas so we don't have to troubleshoot, because that's the last thing you want to do is go out in the field and try to find a problem, especially in a system that big. And it usually works out. I mean, we monitor things very, very closely and make sure everything's running just the way it's supposed to run. Also, I'm responsible for the compliance to our emissions permit here at the university. This actually involves maintaining logs, keeping reports, issuing or keeping records and issuing reports, and then also actually following up, responding to inspections that come up. And then if in the case there's an event or if there's an incident, we have to follow up to that. But the overall idea is try to avoid at all costs, any non-compliance that may be on the horizon. And then also really try to avoid any kind of notice of violations that may crop up. But we've done a good job over the last 5, 6 years, and that we have none. So that's a good thing, actually. As far as the major energy sources here on the university, prior to the boiler plant decommissioning in 2014, our major energy sources were electricity, natural gas, coal, and fuel oil. Now, the last two, coal and fuel oil, the majority of which, if not all, was used in the boiler plant itself. At that time, or actually prior to 2014, the boiler plant was burning in excess, well, around between 6,000 and 9,000 tons of coal a year, which is a lot. And fuel oil averaged about 250,000 gallons that they were burning a year. And all this was to produce steam that would be distributed to the buildings on North Campus and used, to heat the buildings. After the decommissioning of the boiler plant and the phased installation of our geothermal system, our major energy sources actually became, we still have electricity and natural gas, fuel oil, and then we added geothermal and just a little bit of solar. The fuel oil, though, is used basically in 7 buildings on campus. And we reduced the amount from 250,000 gallons, which we use in the boiler plant, to 8,000 gallons a year. So it was quite a reduction. But the overall impact of its decommissioning, I tried to summarize here. We eliminated the coal, we dramatically reduced the fuel oil, which led in turn to decreased emissions. And with those decreased emissions, it enabled Westchester to apply for a reclassification of its permit. When the boil point was in operation, Westchester was a Title V permitted facility, which was a permit issued by the EPA, enforced by the DEP. So you had both the state and the federal involved. And because you were Title V, you were actually labeled as a major polluter. Since the decommissioning of that plant, we were able to successfully apply for and be granted a synthetic miner permit, which is a state-only operating permit. The federal government is no longer involved, which is a good thing. And under this permit, our restrictions are a little bit relaxed, and we are no longer considered a major polluter, which is really good. So big impact, decommissioning that boiler plant. And also with the phased implementation of the geothermal system, we eliminated all the steaming, all the steam pipe network in North Campus, replaced it with the geothermal. So now those buildings are actually heated with geothermal. But even though we phased that system in, there were still buildings on North Campus where we simply couldn't get to with the geothermal. So in those buildings, we installed gas-fired, high-efficiency condensing boilers. This is the best you could put in as far as being as efficient as possible in use of the fuel. So overall, I guess the takeaway is what we did, we replaced an energy source or energy sources that identified Westchester University as a major polluter. We actually replaced them with a renewable energy source, and that would be geothermal. And that was a huge success, actually, an impact on the university as far as sustainability. Just to give you an idea what those emissions look like. This chart in the shaded area here, these are the energy sources associated with the boiler plant. And as you see, they disappeared after 2014. These are the CO2 emissions associated in tons of CO2 that were emitted when the coal was burned or when the oil was burned. These other three are what we use on campus anyway, which would be the natural gas, the electric, and then the fuel oil that's used in those 7 houses. The overall totals are shown here. And you see, in this area here, prior to the decommissioning, we were in the 50,000 tons a year. That's what we were emitting from utilities. This is not like the total amount because there are other sources here. These are just amounts from the utilities. After the decommissioning, you could see we dropped into 30 to 35 tons a year, which was a big effect. So by, again, the impact is we were able to reduce our emissions in the area, 35–40%, which is a big number. And the reason for this chart is to show it, but we continue to monitor all this, as you can see in yellow there. This is through January with fiscal year 2021's emissions due to the three energy sources there. As far as our current energy sources, we both have purchase sources and generated sources. Our purchase sources include electricity, natural gas, and fuel oil. The electricity, Westchester University actually owns its own substation, which is located out there on New Street. From that substation, the electricity is actually distributed to a majority of the buildings on North Campus. And then in addition to the substation, we also have a total of 48 individual PICO services that are connected to other buildings that aren't on the substation. The substation also services Sturspector, which is down at South Campus. For the electricity, to supply electricity, to generate the electricity, we do contract this out to try to get a good price. We work with PSFEI on this contract, which is Penn State Facilities and Engineering Institute, which are a group of engineers and other experts up at Penn State whose services are available to Westchester University. So what we do is when the time comes, contract is up and we go out for another contract, we contact Penn State, PSFEI, and they'll go out and they'll ask other universities in PASHE. So what they do is they collect everything, and by going out with this aggregate of contracts to be taken, we do get good pricing, which is really good. It's good leverage. Right now, we're under contract with Constellation Energy as our supplier. We just signed a 2-year contract in October, so we're good until 2022. As far as natural gas goes, we have 44 individual services, PICO services that come in and service our buildings on North Campus and down South Campus. We have both high and low pressure services available depending on the demand, in the buildings. And also we go out and we contract with a supplier too for the natural gas. It's the same thing. We deal with the PSFEI, they go out, they reach out to the other universities, and together we go out and we get the best price we can get. Now, a couple times we didn't like the pricing at all, so we just went back to PICO as a supplier and a distributor. But in most cases, there's only one time that happened that I can remember. But in most cases, you always get a better price by going out to an independent supplier. As far as the fuel oil goes, as I mentioned a couple times before, there's only 7 small buildings that we have to supply. They have oil fire furnaces. One of them being 114 in West Rosedale. Thanks, Brad. But anyway, when I say fuel oil actually includes the oil used in these buildings as well as the diesel fuel that goes into the emergency generators. We have 28 emergency generators at Westchester University, 12 of which are diesel fired. So we have to keep them full and topped off, to make sure that they're available for service when needed. One other thing I wanted to mention under fuel oil is that as a requirement of our permit, our emissions permit, we are required to use a low sulfur burning fuel. And we have to actually prove this by having the sulfur concentration printed on each receipt. So we do. It's one thing we do is we do use low sulfur fuel, both in the houses and in the generators. As far as our generated sources we generate right here on site, we have the geothermal system. We have a central distribution system that actually services 13 buildings on North Campus. And we have 3 other buildings that have their own local systems. By that, I mean they have their own dedicated well field. That well field is sized and it's designed just for that particular building. The 3 local buildings are EO Bull, 25U, and Tanglewood. So in total, there are 16 buildings on North Campus that are connected to a geothermal system. And then, as I mentioned before, we also have a solar system, which consists of 3 arrays that are mounted on top of the student rec center. And we'll go into that just a little more later on in the presentation. Basically, that there are energy sources right now, and how they're divided into purchased and generated. As far as I mentioned before, one of my responsibilities is to monitor and measure what we use. The majority of the data that we gather is actually based on the utility invoices. This is where we get the amount used in the buildings and the cost, what it's costing us per building. But we also get a lot of data from our BAS system, which is our building automation system. We need both to generate the data we need. As an example would be the electric energy that comes into the substation on New Street. From PICO, we get one bill for that substation. It's a big one, but it's one bill, and it's one that gives you usage at the substation and the cost. Then from there, it's distributed to the different buildings. The way we know how much each building is using is that in each building, we have an electric meter that's set up and connected to our BAS system. So we could go in and we could actually monitor, well, we can record the usage, every month in that building, so we know. Another example would be, in using our BAS system, would be for the geothermal. In each one of our geothermal buildings, we have a BTU meter. And from that meter, we could gather information as far as usage of geothermal energy in that building. We gather all this information, and from that, we can generate campus energy usage profiles for each one of these energy sources. So we know throughout the year, and each month, how much energy we're using, from each one of these sources. And then in addition, what we look at is the distribution of energy, where this energy is being used and how much from each energy source, which I'll show you in just a couple of minutes. And then we bring it even a level further, where we go into the individual buildings, and we have the ability to generate energy profiles for most of the buildings. So if one building would have sources from electricity, gas, and geothermal, we would have 3 different profiles for that, and then we'd have a total profile. So we would know the energy usage in that building. And then also from there, we monitor the energy use index. This is a figure that's used throughout the industry where you measure your energy usage, usually in BTUs, against the square footage of the building. So it kind of levels the playing field. And we look at the energy use index not only for each building, but for each category of buildings. So if we were to look at all the dormitories on campus, we would expect to see the same or nearly the same energy usage index, for those buildings, as opposed to the academic buildings, which may be a little higher, maybe a little lower, but still they should all be the same in that category. And we do watch that. At the same time, we generated energy cost index too. And this is just something I made up, to be perfectly honest with you, where we look at the what it cost us per BTU in each building. And again, according to the building category, it should be just about the same. These are examples, or these are the energy profiles for each energy source for the campus. These are campus energy profiles. So if you look at the electrical use, it's both shown as a line and as bar graphs over here. You could see that we have these little peaks here and here, but basically you're a little higher here and then a little lower there, but it's basically the same. But where these peaks occur, what I want to point out is usually in August, September, right around here. And then again in February, it peaks out, maybe at the end of January. This is when all the students come back to campus. This is why it peaks out. And it's not much of a peak, but it is a peak. But these are the things we look at. And as you see, we've been using less and less energy, through the last 4 years or so. But I want to point out that even though the usage in 2021 is extremely low in this profile for electric, as well as the other profiles here, you have to keep in mind that this is in direct response, actually to our response to the COVID. We went around, we actually shut down or greatly reduced the energy consumptions in buildings because we didn't need it. The buildings weren't occupied. So we just changed schedules, we changed set points, and that's the result of that, that lower usage. If we didn't have to do that, I think we'd still be a little lower, but not that dramatic, So that's directly, from the COVID response. Again, with the gas usage, you see it peaks out December, January. They're the winter months. That's what you would expect. You're using gas to heat the buildings in the winter months. Now, and again, we see much lower usage in 2021, but that's because the buildings, the set points are much lower. If we look at fuel oil and geothermal, fuel oil actually mimics the gas usage. It's a little higher. Peaks out in the winter time because that's when you use it. However, you have to look at the range over here in the MBTUs, where you're 200, you're in the hundreds here. Back in the gas usage, you're in the tens of thousands. So it's a big difference in how much is actually being used. If you look at the geothermal, you'll notice that most of the geothermal energy is used in the summertime, July, August. That's when we're at our highest over here. This tells us that it takes a lot more geothermal energy to cool those buildings than it does to heat them. And this is reflected in what we see during our daily monitoring of the geothermal system. In the summertime, we'll see a much bigger temperature difference between the water going out to the system and the water coming back, and the flow rates are much higher. So we're using a lot more energy in the geothermal from the geothermal well fields. In the summertime, in the wintertime, it's amazing, but a 2-degree difference at a lower flow rate is enough to heat those buildings out there, it's amazing to me, and it always was. But again, this just goes to show that we use a lot more geothermal energy in the wintertime. And from this, we could do just a lecture alone or a presentation alone just on this geothermal, because it explains, why our well fields are heating up and things of that nature. But again, that's another presentation in itself. But this just reflects, what we see, and we know that we're using more energy, to cool those buildings rather than to heat them. The total, if you put all these together, you look at the total. Again, if you look at the total, this reflects what we see in gas and oil. So we're peaking out in December, and we peak out in gas and oil, which says it kind of directs our focus to where we should be looking at in terms of efficiency during the winter time. So basically, it's the same year to year to year. And again, you'll see a much lower in 2021 due to COVID changes. We spoke about distribution before, and this chart gives you a little idea of where our energy is used and how much of the source is being used. These are on the left side of the chart here are different building types. We have E and G buildings, which is educational in general. These are our academic buildings, where classes are, where offices are. Then we have auxiliary building residential, our dorms. Auxiliary buildings, others. This would be dining and activity centers. And then we have USH buildings. I have to separate USH due to budgetary reasons, because this comes into effect later on when we do the budgets, and I have to know, where that line is. And then we further separate into geothermal, non-geothermal. But in looking at all this and adding up all the numbers, and this is for fiscal year 2020, you can see that 57% of our total energy is used in the E and G buildings, is used in academic buildings, whereas 27% is used in our dorms and our other auxiliary buildings, and then 16% in the USH buildings. But the way I look at it is that the USH buildings actually consists of Allegheny, Brandywine, Commonwealth, and University. University being the only non-geothermal. But if you add these two together, because they're basically dormitories, it's actually a 60-40 split between academic buildings and non-academic buildings. But down here along the bottom, if you take a look, you see that most of our energy comes in the form of electricity. That's where our usage is, and then gas, which is fairly close behind. Oil, we're using less than 1%. That's why that comes up as 0, and then 11% is from geothermal. But basically, that gives you a snapshot of where our energy is being used and how much of each energy source is being used. This is just usage by energy source, and it's basically almost a repeat of what we just saw in our distribution. Most of our energy comes from electricity, and then gas. Fuel oil is minor, and then we have geothermal. But if we put a line right down here, on the left side is all non-renewable. On the right side, basically it's just geothermal. This is our renewable right here, okay? So what we like to do when we set goals, when we look for ways to improve, when we look to become more sustainable, we want to bring the bars on this side of the chart up. We want to bring the bars on this side of the chart down, if we can. We got to get that balance right there, and that'll bring us more. That'll give us help to identify our goals as far as becoming more sustainable here at the university. We mentioned energy usage index, which is usage per square foot. There's a U.S. national average out there, and this is a list of those national averages for EUI. If you look down here to education, and more specifically college or university, we should, on a national average, we should be using about 120 kilobtu's per square foot of building, which is 0.12 MBTUs per square foot of building. If we, keeping that in mind, I know you can't see this, okay, and I couldn't get the whole chart on there, but I just wanted to show you that we track this. This is actually over here on the left side. This is actually the same distributions I showed on our distribution side. So this will be for the E&G buildings, and this chart goes down further. But for the E&G buildings, non-geothermal, our average EUI, which is right here, is 0.022 MBTU per square foot, and that's much less than 0.1. It's a factor of 10, which is really good. And then at the same time, I track our dollars per MBTU, and right now for this type of building, we're tracking about 23 bucks a square foot, an MBTU that we're spending. If you go down this chart further, the highest you'll see on that chart is 0.53 for an EUI, and that's for auxiliary dining non-geothermal. So again, we're far below the 0.12 that we're supposed to be if you want to look at the national averages. But right now, I think personally we set our own bar, and we go up and down there. So if we by continuing to do this, we'll generate where we should be on our own average and try to stay at that point. But that chart's back there on my wall, so I know you can see that as clear as day, so we're good. Okay. This I threw in here because it was a little eye opener to me. I just wanted to share it with you. I was trying to determine how much per MBTU that we spend for electricity, for natural gas, and for geothermal. For electricity and natural gas, it's a pretty straightforward calculation because you have all the numbers. So in fiscal year 2020, which this shows here, we could pretty much calculate what it cost us in energy and electricity and gas. But for geothermal, it's just a little more trickier. And this is by no means a rigorous calculation. It just gets us in the ballpark. But what I did, if we take fiscal year 2020, for example, each month we have a BTU meter in the pump house, which tells us what the BTUs are going out to the entire system, and that's registered right here. So in August, of fiscal year 2020, we had 3,948 MBTUs go out to the system. In the pump house itself, the electric we use, and again, there's a meter in the pump house that tells us we use 138,000 kilowatt hours. And based on the fiscal year cost per kilowatt hour, we came up with the cost. So we know the usage, we know the cost, we come up with the cost per MBTU. So we see here in fiscal year 2019, we spent we averaged $3.40 an MBTU to generate geothermal energy. 3.25 last fiscal year, and to date we're 3.46. Compared to right here, electricity fiscal year 20 almost $20 an MBTU, gas almost $8 an MBTU. So you could see. But going back to that one bar graph, by changing that graph a little bit, not only impacts sustainability, but it has a financial impact too. And it's shown right here. Again, this isn't a rigorous calculation. It just gets us in the ballpark. But it shows you there's quite a difference. The solar that I spoke about earlier, we have 3 arrays that are on the roof of the student rec center, and through the BAS system, through our building automation system, we can go back. And I went back to April of last year, and I came up with the amount of megawatt hours being produced by these arrays each month. And right now we're averaging about 2.2 megawatt hours a month, which is good. Okay, but in overall terms, even though this is good, that amounts to about 26 renewable energy credits a year, you know, which is good, but it's much. That's why I said, you know, it's minor. But all the energy that's generated by the solar array goes right back into the building. It's not, you know, it doesn't go back to the grid. We don't get any credit for it. It just goes right back into the building that's being used. But that just shows you, you know, that we do measure this too. We have the ability to measure it. So, and we do keep an eye on it. As far as controlling energy on campus, and this is from an operations standpoint. This isn't, you know, anywhere else. This is strictly from an operations standpoint. Our number one and primary control is through building automation system, the schedules and the set points that we could establish for each and every building. We can go in, we have occupancy schedules, we have non-occupancy schedule, and we have the set point. So by manipulating this a little bit, we can control our energy usage. And hopefully by keeping an eye on us, we get every week, I forget who does this, but we get a record of where events are being held and how long. And we will adjust our set points for that particular building, you know, to accommodate those people, and then they go back into unoccupied. So we're doing the best we can as far as controlling energy, you know, with what we have. We also can control our supplier contracts too. This has a more of an impact on cost than it does on usage, but still it's an impact. So by going out and continuing to try to get the best prices we can, we'll do that, and that's within our control. Renewable energy credits. We control how much we purchase. So we can purchase more, get more credit to go against our carbon footprint, or we can purchase less. And I have a slide coming up to show you our purchases, our past purchases there. So we do have the ability to control that. But the non-tangible is the policies and the culture. Yeah, that's from the university. Basically, Westchester University can set policy and try to create a culture which makes everybody mindful of the energy usage on campus. But I think culture may be more of a personal thing. You know, how do I use energy? How do I go about doing things? Keeping in mind that it's going to have an impact. It's going to impact how much, you know, it's going to impact our energy profiles. It's going to impact our sustainability and this and that. But the idea is, you know, to get the word out there. And believe me, I'm not an expert on this, and I don't have any background. I'm a numbers man. But at the same time, I know how important it is to get that message out there, to be very mindful, to be very conscious, to be very aware of how much energy you're using and in what way you're using it, because it will impact the university and its goals of achieving a high sustainability. The renewable energy credits, what I just mentioned, the amount that we purchase is usually based on how much we use in electricity. In past years, we always purchased 30%. I can't tell you where this number came from or what it's based on, but that's what we did. We always purchased for 30%, which amounted to 12,000 megawatt hours. In 2019, the decision was made to purchase 100%. So we went out, we got 100% right there, which is 45,000 megawatt hours. And then we dropped back down to 30% in the last contract, which was a 2-year contract. When we do go out to purchase renewable energy credits, we again work with PSFEI. We will go out with Westchester, with other universities, and try as an aggregate to get the best price they can. And it works, it really does. But as you see, prices go up and down here. And it all depends on the market and what everything's doing at the time. But right now we're good, through 2021, and 2021's renewable energy credits actually aren't delivered, before 2020, or will be delivered, in the beginning of 2022. So shortly, I expect that we'll be not shortly, but sometime during this year, I expect to be going out, to purchase more renewable energy credits, and I'll be approaching, upper management to see how much they want to buy, and then we'll just go from there. As far as making improvements and having opportunities to improve, I think one of the first things we have to do is continue our, continue trying to understand our buildings and the systems within our buildings. I think this is really key to getting a hold of, to making some improvements. I just want to make sure I don't miss anything. I'm just skipping through my notes here. Yeah, if we look at our buildings, we look at it structural, we look at the efficiency of the building itself. And we not only the buildings, but of the systems. We want to know what the ability of the system is, what the limitations of the systems are, and what can we do to be most effective, in trying to increase our efficiencies as far as energy usage in those buildings. I'm excited about this. One of the key projects that we're working on now is building core temperatures. We want to try and establish what is the core temperature of each individual building on campus. This will tell us where the building, for lack of a better word, idles. In other words, based on its structure, based on its makeup, based on its systems and this and that, the buildings will idle, at a different temperature, a core temperature. That core temperature is, in my opinion, is based on 0-degree days. On 0-degree days, you'll use as much energy as needed to keep that building at a core temperature. So somehow we have to correlate 0-degree days, core temperatures, and use of energy together to establish what that is. If we do that, because I know there's been there's been past questions about policies that address setting temperatures in buildings. And we can go ahead and just say, okay, we'll say 68 degrees across the board. That's what the temperature is going to be. Well, the thinking is we don't want to do that. What we want to do is know what the core temperature is. And then by that, once we know what that core temperature is, and once we know how much energy it takes to maintain that core temperature in that building, we can tell you, okay, if you want to increase your temperature by a couple degrees, this is what's going to take an additional energy. This is what's going to take an additional cost, because we know where the building idles. We know what the core temperature is based on thermal mass and a bunch of other stuff I don't want to get into right here. And then once we know what the core temperature is, we can move over and see, why is it that core temperature? And that's when we can look at building structure, building envelope, ventilation rates, usage, occupancies, and things of that nature, because that all come into effect. And then to bring it a step further, do we want to change that core temperature? And if we do, what will it take? So again, this all plays out, but just getting to the core temperatures would be a tremendous, in my opinion, would be just a tremendous accomplishment, and trying to understand exactly how that building functions as far as energy usage and maintaining temperature. And then moving on from there, as I said, to why it's at that temperature, and then if we want to change it, what it will take to change that thing. But and it's funny because I had plenty of discussions about this with plenty of people, and actually, what we should be looking at, and what we're going to look at, we're not going to look at temperature. We're going to look at enthalpy. We're going to look at building enthalpy versus outside enthalpy, and I think that'll get us to the core temperature a little faster. But again, this is all in the works, okay? And I don't want to be giving away my secrets. So anyway, electrical peak demand. I forwarded PSFEI 3 years of interval data from our substation, as well as some of our major building users of electricity. And what I asked them to do is, look for when the peaks occur and how often they occur. And then what we'll do is we'll look at the buildings and see if those peaks occur at the same time. If they do, we can then look at the equipment and see what we could do with the equipment to bring those peaks down, which will bring the peaks down in the hopefully bring the peaks down in the substation, and save us some money and some usage. So. Basically, but that's in the works too. And PSFEI has all that data. I've looked at data from our BAS system, did the same thing, come up with what I thought when things occurred and how we could do it. But it's always nice to get the experts involved, and say, you take a look at it, see what you see if you see the same thing. So that's in the works too. AECs, which would be alternative energy credits. This is another way we can really affect our carbon footprint. And the approach I'm taking is I reached out to a number of people to find out about alternative energy credits. The approach would be for Westchester University to be issued certified credits for the geothermal energy that's created or generated and used on campus. We want credit for that. We want that to go against our carbon footprint, but we want it certified. We want certified credits that nobody can challenge. And again, we're looking into this to see what it'll take. How do you do this, and if we can do it? But I think it's something that will be very, very beneficial to us, and I think it's well worth doing. And again, this wouldn't be usually people who generate renewable energy credits generate them to sell. We won't sell these. I'm not looking to sell. I'm looking to just get to claim them. So we can claim them against our carbon footprint. That's it, but I want to do it officially. But we're looking into that. Power purchase agreements. I know Brad's very familiar with this. He's done a lot of work on this. But if we could get a power purchase agreement in place where we use solar power, either alone as Westchester University alone, or in an aggregate agreement with other PASHA universities, that would be great, because again, it would have a tremendous effect on our carbon footprint moving forward, and we would be locked into a price, so it would help us with our budgets too, big time. FCAs, facility condition assessments. This goes back to understanding buildings. For our facility condition assessments, right now, the operations department here in facilities is conducting these assessments with an outside engineering firm, and it's pretty intensive. They're actually, in my opinion, it looks like they're recommissioning the buildings. They're going in, looking at structures, systems, makeup, everything. And they're going to give us a full assessment of the building systems, and then give us recommendations on which way to go to become more efficient. And this will help us out tremendously, and I'm hoping to use some of this information as part of trying to determine what our core temperatures are. Expansion of the geothermal system. This is a big one here as far as the university is. I mean, we're unique right now with what we have in place as far as geothermal. There's no other university except for Ball State that has a system like ours. And even Ball State isn't like ours, they're a little different. But if we could expand our system, get more buildings on geothermal and off of the conventional types of heating and air conditioning, it would not only reduce our costs, reduce our usage, but it would also have an impact, on our carbon footprint as well. And again, it goes back to that chart. We want to raise the bars on the right side and lower them on the left, and this would have a big impact on that. Right now, the SECC building is set up to go geothermal. They're also set up to use conventional heating and air conditioning. The reason that it won't go geothermal, won't be connected to geothermal right away, is because right now we're limited in wells. We don't have the capacity in wells, to support a building that big. But it is set up. Somebody thought ahead. Somebody, very, very well forward thinking, and that when we're ready, we can hook that up almost immediately when we have the wells, which is good. And I think there's other projects in place where they're looking to put buildings on geothermal systems. Some other things we could look at and are doing right now, replacing conventional lighting fixtures with LEDs, expanding our use of occupancy sensors. I know in a lot of buildings we have our motion sensors, which turn things on and off. But with an occupancy sensor, you go in, you leave, it turns off, it stays off until you turn it on again, which is a little better. We could also look at plug loads, electric vehicles. We have a bike program and our snow melt systems, things of that nature. These are just other things that we could look at that we can consider doing, or that we are doing right now, as far as opportunities to become more, to increase our sustainability. And that actually concludes, oh, look at that. That actually concludes, I was looking at my clock, sorry. That actually concludes my presentation. If there's any questions, I'll be happy to answer, or if you think of something later on, please, don't hesitate to contact me. My contact information is there on the slide.
Thank you so much, John.
Yes.
We are right at 12:50, and that's the official end time of the seminar. So if any of you who are still on the call need to log off, please feel free to do so. But John, if you have a few more minutes and can take some questions, yes. For those of you who can stay on, please do. I know I have a bunch of questions, but I'm going to be quiet and let some of our other colleagues jump in first.
That's fine.
Can I jump in?
Certainly.
Thanks. Yeah, I was taking lots of notes while you're talking, and that whole idea of the core temp sounds really exciting because I'm a main hall resident.
Yes.
And that, that place is just wacky. Even now when I go to campus, it just seems like, why is my office so hot? No one's here, but that's another issue. I had two questions. If you could talk about why there was that move to 100% RECs and then back to 30, why we didn't stay at 100, if the purchasing of 100%, and then
the only
okay.
To be like perfectly honest with you.
Yeah.
We were at 30% while the associate vice president of facilities was Greg Kuprak. He always liked 30%. The next guy came in, I forget his name now. He went to 100 and then he left. What was his name? I forget his name. And then it went back to 30.
Yeah.
But I mean, I'd be perfectly
Okay.
honest with you, that's the way it happens. I mean, I don't know what else they base it on.
Right.
But
So
I'm
that's
sure
interesting.
now, I know with Gary in there,
Mhm.
he's wide open, to comments, to recommendations, especially from, Brad and sustainability.
Mhm.
So if you want to make those, if you want to have that discussion with him, if you want to make those comments, because it's, he holds the money. So, so
Yeah,
it's,
but if we're locked in for 2 years, you said,
yeah, I
right?
mean, I
Yeah.
hate to give you a short answer, but in all
No.
honesty, that's the answer.
Well, and my other question may not be one that's in your ballpark as well, but apparently, right, because of the way your graphs went down, we're not using as much energy, so we're saving money, right,
Yes.
in our energy area. So I was just curious as to, well, where is that money now going? Is it going into
Well,
more renewable infrastructure for us, like the expansion of the geothermal or other things?
um, that's that's a little above my pay grade. But no,
I
but
know I'm
in all
terrible.
honesty,
Sorry, I
though,
don't mean to put you in the
you
spot.
you have to keep in mind that we're only looking at energy sources. We're not looking at all the utilities, water, sewer, things of that nature. Those prices actually went up because the less you use, the more it costs you per unit volume. So there's a balance there too. So even though we're saving a lot on energy, we are spending a little more on the water only because, and it doesn't make any sense, but that's the way it is. You use more, you pay more, you pay less per gallon. You use less, you pay more per gallon. But when it jumps, it jumps. It's not like a linear or a balanced thing. Yeah. But no, those savings are earmarked for, I guess, because I know that they are looking at different projects involving the geothermal system. One project was to bring actually a consultant in here, and I think it's all set up because I spoke to the consultant myself to help us become more efficient. And of course, that's going to cost you money. And we were waiting, for money to become available to bring him in here so we could together, take a hard look at our system and see what we can do, as well as look at the expansion of it. So the long and short answer is that I do believe that they are looking at things, to expand the geothermal system. I think there's actually a project in place where they're looking to bring geothermal down to South Campus, specifically the Sturzbecker at Sturzbecker. But again, like officially, I don't know, but I'm sure that all the money that's needed for these projects and for this consultant to come in is being gathered.
Thank you. I appreciate that.
Okay.
Any other questions, Walt or Kristen or Lorraine?
Okay.
No, thank you. I was just trying to follow along. Energy is not, I guess you could say, my expertise.
Uh-huh.
But I do understand the importance of it in regards to sustainability. So I was just really trying to follow along on the big picture.
Great. And I think, John, you've given us a really good picture
I hope so.
of the big picture.
I hope so.
I think one tool that you didn't go a lot into detail about, but that would be helpful for those of us who are not experts in energy management, is the energy dashboard that you've helped create, that allows us to take a look on a building by building basis, energy use for these different sources of energy. Could you tell us a little bit about that dashboard and how we
Yeah.
can use it?
If you go onto the Westchester website under facilities and then under sustainability, you'll see I forget what it's called. It's sustainability, and then it's energy something or other.
Mhm.
And then under that, there's there's a series of buttons you could click on. And if you click on all buildings, there's a set of, actually, we just added to this, Brad. We just put more, we put these profiles in there. So you'll see them too. But under all buildings, you'll click on individual buildings. And then if you click on one building, it'll bring up a bar chart. And I think most of them compare this year to last year for all the energy sources that are used in that building. This information comes directly from the BAS system. Okay, I don't actually put any numbers in. I don't plug anything in. It actually gathers the numbers directly from the system and then updates these bar charts that are in there. But it's a quick and easy way to see how energy is being used in that particular building compared to last year. Some of them aren't quite up to date. I was looking at it the other day, which I'll take care of. But most of them are, and it's you have to look at it a little bit. It will give you month to month, and then on the side, it gives you the past week too. So there's a lot of information there. But if you go in there and you have any trouble at all, either understanding it or getting to it, please give me a call, because I'll walk you right through it. It's no problem at all.
Thank you. And could you give us a quick sense of how great the range is in terms of building energy efficiency for our academic buildings? Do we find that the new Business and Public Management Center, which is LEED certified, has a very different level of energy consumption compared to an older building like Main Hall?
Yeah, we do see those differences, both in the profiles and in the overall use. I don't have those numbers in front of me. I mean, right now I could get them, but right now I could tell you, yes, there is a difference. I'd be happy to actually pull a couple of them up, when I get a couple minutes and send them to you. But yeah, as you mentioned, Main Hall, that's that's just a thermal, it's a thermal mass. That is. But
do the conclusions you can draw from looking at building energy use help you and your colleagues in facilities prioritize where to make energy efficiency upgrades on campus?
Yes, because you want to know where to concentrate. You want to know what to attack. And this kind of points us in a direction. It's not real specific, but it kind of points you, in a direction. And then once you get into a building that's more of an energy hog, you start to look at the systems and try to figure out what's going on. In some cases, there's nothing you can do because the building is running, as best it can. There's nothing you could change in the building. You're not going to add insulation or anything like that, because the building's old. But at the same time, it does give you the opportunity to go in and maybe put in like a VFD if you can, on some of the pumps, on some of the motors, to try to make sure that it isn't all out.
What's a VFD?
Variable speed drive.
Okay.
In other words, when you turn a motor on or a pump on, it's 100%, and it'll stay 100% until you turn it off. With a VFD, it'll ramp it up and try to match the load, and then it'll ramp it back down. Things like that. You can do that in some of the older buildings, but to tell you the truth, most of the older buildings have that right now. But in terms of pointing us in a direction, yes, this is a good tool. This is a very, very powerful tool in doing that.
Well, John, we're at 1 o'clock and I know I need to log off, and I see other people need to now. So
no problem.
Thank you very much for sharing your expertise with us.
You're very welcome. And as I said, any other questions, please feel free.
Okay.
Okay. Thank you.
Thank you, John. All right. Goodbye.